So we saw in the last part of the video how we can use data about the amount of each chemical, carbon, hydrogen and oxygen in a compound to work out its empirical formula. But how do we get this information? Well, we can use combustion analysis to find the percentage composition by mass, assuming that only carbon, hydrogen and oxygen are present. We do this by burning a known mass of the compound and using absorbers to collect the carbon dioxide and water. So we would have one chamber of our apparatus here, where we have the compound, and then in these attached chambers, where once we've burnt the compound and we've generated gases of carbon dioxide and water, they're going to pass through these two other points. The first is going to contain a carbon dioxide absorber, which is just a chemical which will pick up the CO2 as it travels through. The water will pass through this chamber more or less unheeded, but it will then get trapped by the H2O absorber in the next part. We have an input for oxygen at the start because we know we need oxygen to be able to combust anything, and we have an outlet at the end for any unused oxygen to be able to escape. The way we carry out combustion analysis is to apply heat to this chamber here and burn the compound. During the combustion, we'll generate the CO2 and the hydrogen, and these will get caught in the absorbers. We then measure the change in mass of each of the absorbers after we've burnt all of the sample, and then we can find the mass of the gas collected, because any change in the mass of these middle parts is going to come from the gas that's been trapped in them. We can summarise the type of data we'd collect in a table like this, where we know the amount of compound we've burnt is 1.65 grams, and then the amount of carbon dioxide that got trapped in the absorber was 3.21 grams, and the amount of water that got trapped in the next absorber was 1.13 grams. So carbon dioxide is only made up of carbon attached to two oxygen molecules. The oxygen comes from the oxygen we burn the sample in, but all of the carbon within the carbon dioxide is going to come from the sample itself. This is where we're getting that source of carbon. So if we think about the fraction of the mass of this whole CO2 molecule that's going to be carbon, we know that carbon itself weighs 12 grams per mole, and then the total carbon dioxide molecule is going to weigh this 12 grams per mole from the carbon, plus 2 lots of 16.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.